Okay, so we were talking about the least squares regression line. So in the last lesson, so we were now getting our scatter plot, and we're getting that least squares regression line, which is the A plus BX. And we know that the B is the gradient and A is the y-intercept, and we were looking at a few ways of finding those values. All right, so with this first question, it says we've done a statistical analysis of two variables, x and y. So this one's okay. We don't need to work out which one's x or the explanatory or in response. They gave it to us. Now, it says using this information, find the value of the correlation coefficient. So if we go back and we saw, you can see we got given some statistical data. So we actually have a formula for that one. And it was this. So if we go in, so I've got to find the B value. Now they've given me the B value in the equation. There's the B value. So we've got 1.31, and then it's times the standard deviation of x, which is 2.33, over the standard deviation of y, which is 3.24, and I get 0.9421, so D is my answer for that one. Okay, in the next one, the least squares line of the form y equals a plus bx is fitted to the set of bivariate data, and the variables x and y, and they've given us a little bit of the statistics there. So it says now for the question, it's asking me for the slope or the B value. Now, if I go and write out my B value formula, so B value is actually R times SY over SX. Now, if I go and look through my data, I don't have R there. R's missing. So there must be another way to find this. Now, because they gave me here, they gave me the A value. So I do have a formula, and if you remember, the formula for the A value had the B in there. So there's that slope written here. So if I have got all the other pieces of data, which I do, so A is 3.1, the mean of Y is 5.6, minus B, and we know the mean of X, which was 5.5. If I do that, I can just use the solve function and go comma A, okay? And that's going, comma B even. And that's going to help me find that B value, and we ended up with B equals 0.45. All right, so I'm tipping there too that if you didn't round it properly, it would have been 0.44. So be careful. Okay, so in this next one, a study was conducted to investigate the effect of drinking coffee on sleep. So in the study, the amount of sleep in hours and the amount of coffee drunk in cups on a given day were recorded, and the following summary statistics generated. So what you have to look here is we need to decide which one's our response and which one's our EV with this scenario. Now, because they're saying they don't want to check on how much you sleep when you drink, so much coffee. So the response, what we're looking at is the response of sleep. So sleep becomes our response variable, and the coffee becomes our explanatory variable. Now, once you've worked that out, I like to put them on the top here because they've actually listed the Y first. So we know response is Y. So maybe write the mean of Y and then the mean of X and S of Y and S of X there, just so you know which one's which. Okay. Now, here it says on average, for each additional cup of coffee drunk, the amount of sleep. Now, yesterday when we were talking about this equation, this Y equals A plus BX, and I was talking about the B value, I said to write down words next to it. I said often you'll hear the words this next to it. And what were those words? I said when you had your B value is the slope or the gradient. And I said often they use the wording on average. So here, they're saying on average. So what they're saying, on average, for each additional cup of coffee, the amount of sleep, because the gradient, the B-value, will either increase your response or decrease your response, but depending on whether it's positive or negative. So we've seen this on average, so we know, right, we need to find the B-value, and I'm going to use that B-value formula, with the one we've got R over SY over SX. So I can find this B-value. Now they gave me the R there, so I'm going to use that one, and they've given me all the other things like standard deviation of Y and standard deviation of X, and I end up with negative 0.55. Now that word, that negative, when we write that out in a statement, we say decrease, yeah? So we don't need to say, write the negative when we're talking about it in words. We say the word decrease. So for this one, because the gradients are negative, every time we add a cup of coffee, the sleep is going to decrease by 0.55 hours. So which one is the answer there? A, good. So you can get away with going, all right, when I see the word on average, they're talking about the slope, the gradient, the B-value. This leads a little bit into 3B, where it'll become more familiar with you. We'll start talking about the gradient and the y-intercept a bit more. Okay, the next question. The least squares regression line was fitted to this monthly average temperature and the latitude, and there's the equation below, and it's asking us this equation rounded to 3 significant figures. So the numbers that you just have to round, there's 2 numbers to round. So the first one, the A value, which I'm just writing out what they've got it at, which is this. So if I'm doing it to 3 significant figures, I count as soon as I have a non-zero. So 1, 2, 3. Now I have to check the fourth one. Now the fourth one is above 5. So that means this guy has to go up. Now that's 9, so it means it pushes that one to go up. So 3 significant figures is actually going to be 43.0. And you would have to have the O there. So if this was a short answer, because it said 3 significant figures, you'd have to have 0.0. So then we have to do the B value to 3 significant figures as well. And this one's pretty easy because there's no rounding up. Because if we count 1, 2, 3, the first non-zero, the last one's a 4, so it's negative 0.877. Oh, sorry. Yeah, 877. So which one was the answer for that one? E. Good. Last question is, once again, it'll come a bit more easier once we've done 3B, but it'll help us lead into it, so let's talk about it. So it says, in the study of an association between person's height in centimetres and body surface area in square metres, the following least squares line was obtained. Okay, so which of the following is a conclusion that can be made from this least squares line? So it says an increase in 1 metre squared body surface area is associated with an increase in 0.19 centimetres in height. What that one is, it's not correct. And what they're saying is, if I push that number up, will it push this up by 0.9? It doesn't. It's actually when you want to interpret the gradient or the B value here, it's when you interpret that, you often say when you increase that by 1, so the height, if I increase the height by 1 centimetre, because this gradient is a positive, if I increase this by 1 centimetre, it increases the the Y, or the body surface, by whatever the gradient number is. So it increases that by 0.019. So the answer is actually B, because you can see that's what I exactly said there is what happened. So the first one is there to throw you. We're going to get better because we are going to write these statements and we're going to know what should be written. Okay, the next one, you should have been able to hopefully eliminate this. The correlation, it's not that. That's the B value listed in there. Get rid of that. And these last two were questions. Even if they're, whatever they're saying 1.1, they're using like the A value. We would never interpret anything like that. But they're very gross statements anyway. We shouldn't really say that, like a person's body service. It should be, see how the top two are saying are associated. We're not really saying associated in those last two. They're very generalized statements anyway. They're wrong, but they're generalized that we would get rid of them anyway. They don't have our wording that we like, all right? Okay, so I'm not going to go through all of, we had the first 10 questions of the Northern Hemisphere, but I'm going to go through a few of them that I could tell. Okay, so here we've got the questions. It says using the following information for question 3 and 4. So this is really important that you take note of this and maybe just highlight and go right, knowing that they're grouped. So any information given could be used to solve those questions 3 and 4. Okay, so what we've got is a histogram here with a log scale, and it's said that it's log 10, but we are always going to use log 10, so you don't need to worry. So what I often find helps is that I like to change the scale to the actual number, what it actually means. So then, because that's what they generally ask in the question. So what you have to remember, when you have a log number there, all that simply means is the actual number is 10 to the power of 2. And what's 10 squared? It's 100, isn't it? So that one's 100. And now this one is 10 to the power of 1. What's anything to the power of 1? Or what's 10 to the power of 1? 10. And then we've got 10 to the power of 0. What's 10 to the power of 0? 1. So now you know that that's 1, 10, 100. So you can see now, maybe not change all of them, change a few so you're in that mind of thinking. And then it says the percentage of craters in this sample with a diameter less than 1 kilometre. So we just worked that out. That was the 0. So that is all that way, less than 1 kilometre. And they're saying percentage. So remember, percentage is an amount over the total times 100. So we want to know, first of all, we want to know the amount. So if I added them up, I've got 4, 4, 7, so that's at 15, 16, 17. Okay, so we've got 17. Now out of the total, so the total we had, we got up to here, if we were adding them along, we got up to 17, and then we add another 4, so it equaled, there was 21 in total, okay, times by 100, and I believe it was 81%. Now, question 4, the median diameter in kilometres, so median. So remember, we find the median at n plus 1 divided by 2. So we know it was 21 because we just worked that out. So we're going to say it happens at the 11th spot, the median. So if I do my running total, 1 plus 1, that's 2, plus 7, that would be 9. Then down here, the 11th occurs in here. Would you agree? So we're saying the 11th occurs somewhere between 10 to the power of negative 2 and 10 to the power of negative 1. If you're not good at it, just plug that number into your calculator and you'll see you get 0.01 and 0.1. Okay, so which one's the answer for this one? B. The following questions are for 5 and 6, so just take note that we are using the same thing. So it says in this study, the percentage of parcels that had a delivery time of 3 or more days was closer to. So 3 or more days was along here. So because they're asking me for percentage, so remember percentage equals amount over total. All right, so that that amount was, if we add all them up, was 30. And if we look to find the total would be all these numbers added up, which I believe add up to 90. Okay? And then we would times it by 100, and we end up with 33%. The next one, now this is where we were thrown a little bit. We had this question in the notes, but without the other part. So I said I can only assume delivery time was measured, but in this one, it says to use, it relates to the other question. So or the other information. So when it says delivery time, that's up here, delivery time. That delivery time is actually, that's a categorical, yeah? It's categorical, and it's, you might say ordinal. And then the delivery distance up here is also in categorical. And it's ordinal, but it's categorical. So now if I go through, I've got two categoricals. So if you look at your table sheet, the table that has a summary, you can go through. Now, it wouldn't be a back-to-back stem plot. I have more than two categories there, so that's out. It's not a time series plot because it's not numerical and numerical. So in this instant, we can see it's not. The parallel box plot, a box plot is done when you've got a numerical and a categorical. We've got two categoricals, yeah? And a histogram is when we've just got a continuous numerical data as well. So we get rid of that. And so we ended up with only a segmented bar chart is our best one. So this one is a parallel box plot, and the same thing, the questions are relating, and it says 44 people. So some of this information is going to be handy, I assume. So I'm just going to write N is 44. Now, question 7, the number of people from the sample with a bicep muscle circumference of 22 and greater. So if we go greater than 22, if I look here, here's 22 and greater. So it's pretty much everyone bar 1. So what is it going to be? The 44 minus that one outlier. So what do we get? 43. With the next one, it says the percentage of people from the sample with a bicep muscle circumference between 26 and 34. So if you look at here, 26 and 34 is there, okay? Now, what you need to understand is when you have a box plot, these sections here, say like this section all the way up to there is 25%, yeah? This next box bit is 25%. This next bit is 25%. And then this last bit, and it includes the outliers, is 25%. So if I go from here to the end, from 26 to the end, that includes that's 75% of the data. Okay, but they only want it up to there, which I can see is everything bar those 3 little outliers. So what I'm going to do is I'm going to go, all right, what's 75% of the data, which was 44, and then I'm going to minus the 3 outliers, and that's going to tell me how many are between the 26 and 34. So if we do that, so remember some people wanted to know, we change that to a decimal, we times 44, and then you go minus 3, and you end up with 30, okay? So they want a percentage. So a percentage, remember, will be the amount, 30 out of the total, which was 44, times 100. And it ends up being, I believe, 68%. Okay, so the mean bicep circumference for the 44 people in the sample was 28.16. The people whose biceps muscle circumference is an outlier are then excluded, and the mean is recalculated. Okay, the new mean bicep muscle circumference will be. All right, so first of all, if you look, how do you find the mean? The mean is you add up all the values and you divide by n. Okay? So if I look at the original mean, so the original mean was 28.16. So they must have added up all the values and divided by, I'm going to say 44. Yes, because there was 44 things. So what I need to know, if I want to get the new mean, so the new mean is going to be all the values added up, all the values, but minus the 4 outliers. Would you agree? Yeah? And then plus or divided by, there was 4 outliers, so it would be divided by 40 now. So what I need to know is I need to know all these values. Yeah? I need that value there. So the way you can do it, now it depends on how you're good. If you want to do it, you can just change this. We could just, it's dividing there, so we'll times it there, and that's going to give me all the added values, yeah? Okay, so if you do that, okay, so it ends up being, this ends up being 1239.04, okay? So over here in the new mean, it's going to be the 1239.04, and then I'm going to minus the 4 outliers, which you can read off. I'm pretty sure it's 21 plus 35 plus 36 plus 38. So you minus them in there and you divide by 40 because you only have 40 now. And you end up with a mean of 27.73. The final check was revealed that the value of 20 was incorrectly recorded as 21. If the value of the outlier is corrected to 20, the only statistics for which the value will change is. Now, if you remember, the median, the first quartile, the third quartile, and even the interquartile range, they are all resistance statistics, meaning they are not affected by outliers. So when that 20, is it still going to be the smallest value and an outlier? Yes. So the only thing that's going to get affected is the range, because it's the minimum value, so the minimum minus the maximum, okay?